Okay, hey everybody. Welcome to another episode of The Social Brain. This is, I think, our fourth Patreon only episode, not quite sure. But today we're talking about evolution and development. We're sort of bringing together what we talked about in the last couple episodes to a more informal discussion. So we'll just be sort of talking, see where the conversation takes us, reflecting on what we learned from the last couple episodes, and bringing it together with stuff that we talk about on this show more generally. So yeah, I hope you enjoy it, and we'll just jump right into it. Welcome to the Social Brain. I'm Andrew.
And I'm Taylor. And this is a show where we dive into how the brain works. If you've ever wondered what's going on inside your mind, even the things that you're not even aware of, then this is the place where we can unpack that and really explore it.
So I think first, I like to think about what was your biggest aha moment, or what was like your favorite thing to learn about throughout the last couple episodes.
Yeah, that's a good one because this was really cool research, and this is a topic that I've had a lot of fascination with for a long time. Both of them, actually. I've had this really big desire to understand evolution. I have this really kind of nerdy uh, art project that I did a while back. I had one of those printers that prints high def photos, and I had this room that had like rafters on the ceiling, and I was like, you know what? I really want to know like more about evolution. So I'm going to just like map this thing out. And I started at the Big Bang, and I printed, I think at the end of it all, I think I had like 4,500 pictures that I had printed. I had probably spent like close to $1,000 in ink to create this whole thing. But I mapped out from the Big Bang to like now. And I had like the formation of the first galaxies, and then like the formation of life, and like asexual versus sexual reproduction, and then as microbial life kind of expands, and really got into like all of these major extinctions that happened. I mean, when you really look at it, the fact that we're here right now is pretty crazy. Like there have been, I think, I can't remember off the top of my head, but close to like 6 to 9 like major extinction events where like 90% of the species on the entire planet went extinct. And we're still kicking, right? So like, and a lot of that, the really interesting thing when you look at a lot of that is that those major extinction events actually kicked off a lot of the really cool evolutionary growth that happened, right? Because you have this huge like swath of predators just gets wiped out. Now you have this really small, like 10% of life is now like has free reign on the whole world, and they can find new niches and they can do new things. And so for me, like this has always been something that was really interesting, and something that I fell prey to back in the day. I even have one of my early like YouTube videos when I was doing my YouTube channel. I fell prey to the triune brain theory. And I think that we kind of talked about that in the evolution episode, this idea that the brain was constructed in these different evolutionary stages where you have like the reptile brain, and then you have the like the mid limbic brain for the first mammals, and then we have this like special cortex. But I mean, as you dive deeper into this, and as I really started to start listening to like Paul Chiswick and Luis Puelles, and like these people that do really, really interesting comparative biology work, Leah Kubritz, but they have this very different view that like all vertebrates have had all of the parts of the brain since like the first vertebrates, and the big difference then is how we use the brain, and I think that right there has been the most fascinating thing for me in all of this research, is that the shape that our brain takes is so experience dependent.
That's such a good point. That's so interesting. And I like to just imagine you as this all these pictures of all these thousands of animals in your house, like a conspiracy theorist drawing lines from one to another, like on your wall. But no, that is awesome. I never knew that. That's really cool. No, I had a similar journey. I first got into biology before I started my college major, by reading Richard Dawkins and just being fascinated by the idea of evolution. So I was very similar. Evolution and neuroscience were like always sort of tied together for me. But yeah, no, I agree about when it comes to brain evolution. That was definitely something that, the triune brain theory. It seems like there are still prominent people who kind of use it as a shorthand, like Robert
Yeah.
Sapolsky,
Mhm.
and others. I mean, one of the books on my shelf, A History of the Human Brain, he kind of uses that as a shorthand, because I do think there's something to it, right? Like when you look at the brain of a fish, right, or a reptile, you see a much smaller cortex, and a much greater proportion of the brain is brainstem and, hypothalamus and those types of regions that are involved in kind of more bodily functions, and even like autonomic and fight or flight type of stuff. And then as you get to humans, through the course of evolution, you see more and more of the brain, the proportion of the brain is cortex. And actually, I was just reading this article this morning that was super interesting about, if you look at humans, even compared to other mammals, and even compared to chimpanzees and our closest relatives, the great apes, so chimpanzees, gorillas, bonobos, and orangutans. There's these really interesting studies where they take the cortex of each of these species, and they can like dissolve it into just the cells, right? So they can count the nuclei, so they know exactly how many cells are in the cortex. And it's super interesting because humans have uh, more cortical neurons than an elephant or than a whale, even. And that's like amazing. So they have the whale or the elephant has more neurons overall, but it's all packed into their cerebellum and their brainstem. Whereas humans, a much larger proportion of the number of neurons in our brain are packed into our cortex. So I do think there's something to that you know as we evolved, our brains devoted more and more to kind of cortical development.
That's really interesting, right? So the video that I was referring to, if you go back in my YouTube channel, it's the brain's hierarchy of needs. So it was kind of this like borrowing from Maslow, this idea of like the hierarchy of needs psychologically, but looking at like brain evolution in terms of like, okay, what was necessary for some of these animals, like you mentioned with like reptiles and things that are not very social, that don't have this kind of like long distance stuff that they do, and like memory in a certain sense. Like they have memory, it's just not the same as like us and some of these higher order mammals and things like that. The reason I left the video up is because I still think, like you mentioned, that there still is an element of the triune brain theory that still serves the purpose of understanding like what these different parts of the brain are actually responsible for, right? The part of the triune brain theory that's wrong is that it evolved in different steps, that there's like these different regions that just kind of came out of nowhere. And the reason why that's so implausible is because it's really hard to add something new to DNA. It's a lot easier to refine something that already existed in your DNA. And so, like Paul Chiswick's idea of phylogenetic refinement is this idea that we already had all of these pieces, but now we're just kind of making that piece do something more elaborate, right? We're using it more. And something that really kind of struck me, and the reason I left my video up, was because I still believe in the fact that like the lower parts of our brain, the brainstem, all of these things are very responsible for like the lower ends of the hierarchy of needs, right? It's like it's taking care of our need for thirst and for hunger, and you have stuff there that's the first signals for safety as you kind of move up, right? But then when you get to some of this midbrain stuff, some of this emotional stuff, you have these dopamine centers, these reward centers, these things that are pushing kind of motivation towards interaction with others, towards moving towards things that aren't just food and water, right? You're moving towards social interaction, acceptance, recognition, all of these things, especially as you become a human. And then the cortex is something that allows us to really understand everything that's going on underneath, right? To really think about, okay, why is it that we have these needs for thirst and hunger? Why do we have these needs for acceptance and belonging and all of these things? And how can we use our knowledge of why we have all of those needs to then plan for the future, right? And that's where the cortex becomes really, really interesting, and human evolution in general. As we move into our next episode, is going to be all about time. Something that's amazing about being human is that we can use this cortical area that now, like Andrew said, has a lot more neurons because we've devoted so much more energy to that part of our brain because we need to use it for the things that we do as a human, that now we can see 10, 15, 100, 300 years in the future, right? There's an interesting thing we'll probably bring up next year, or next episode, next year. But that this there's a person that we're looking at right now for some of our research that said that humans are probably the only animal that understands the cause and effect of pregnancy, because there's such a lag between sex and birth, right? And so that's where I really kind of enjoyed a lot of putting this stuff together, was that like there still is this separation of function, and I think that it's very tied to kind of the needs of the organism, that like the stuff in the back needs to come first. We need to eat food, we need to have water and air and all of this stuff, and then the like self-actualization, thinking about the future, that stuff can get put on hold. I mean, go back to our stress episodes, like that's the stuff that gets shut down when we're under stress, right?
Yeah, for sure. For sure. And no, I always do kind of, this is definitely a tangential point, but I always kind of take issue with that idea that other animals don't see far into the future. Because there's just, I think Andrew Huberman mentioned this, or something like this, that there's just really no way, like, there's no evidence that we can point to say, like, oh, they don't think about the far future. It might be that they don't act on that, or they don't have the capability to do it, and that might be unique to us. But it seems hard to establish that, especially other animals, like other primates, aren't seeing that far into the future, especially when you consider you know uh, primates like chimpanzees, the great apes, having this very highly developed prefrontal cortex, and we know that this is so important for our future thought, with the caveat that they also don't have the brain regions required for language, which clearly is extremely important for our ability to think and just even conceptualize far into the future. So I think that's a fair point. But anyway, yeah, that's kind of tangential there. I just think it's fascinating to think about the how why did humans develop language? Why did we need that adaptation, or what drove that adaptation, and how did that interact with what was driving maybe our need to think about the future, our ability to conceptualize the future. Those are all those evolutionary questions that, I mean, I'm not an expert on, but it's just fascinating to consider.
And it really looks like like it's this brand new module that just, it's like the 2.0.
Yeah.
All of a sudden you add language to this system, and it's really interesting because language then integrates into all of these other systems. Like when you look, I think we're planning on doing a whole episode about language, but you look at this work by Andrew Huth, or Alexander Huth, that shows that like language is everywhere in the brain. Like you can find evidence for certain like perceptions of words and actions and all of these things in motor cortex and somatosensory cortex and auditory cortex and visual cortex, like all of these different places. And so it shows that like once we developed this ability to start thinking symbolically, we were able to back propagate that to like all of these other regions. We were able to say, okay, now let's just like add this new module onto everything else. And now we can turn visual perceptions into language. We can turn auditory perceptions into language and somatosensory. And it creates this whole new map, this whole new like lexicon, right? That allows us to travel in a different space, right? Because I think that a lot of what came out of the evolution episode is that a lot of evolution is pushed by the need to move, right? We need to move through space. We need to get things. We need to get water. We need to secure resources for ourselves. But now, when you add language on top of that, now we're moving through conceptual space, right? And it's still a type of movement, but now it's kind of like a movement through planning space. And then all of a sudden, our working memory capacity just like blows up as humans.
Yeah, that is so cool. The language, I mean, is definitely distributed throughout the brain. It's not just one region. I remember talking to Gregory Hickok, who has this model of language in the brain with David Popple, and they're both big in the neuroscience of language. And the idea that there's these multiple streams of processing for language. So just as we have the kind of what and where streams for vision and for audition, for other sensory perceptual faculties, we also have something similar for language. And I wonder, if that's a general kind of feature of the brain, where we have these multiple processing streams, and then language, once it was developed, sort of tapped into that in the way that you were describing. Like, it seems like the brain is kind of, in a lot of ways, like an integrating system. Like
Yeah.
it's all kind of working together to do one thing or do various things. And so, like, once you have a new module like language, it can integrate that into uh, many different brain areas, can kind of work together to integrate that into the rest of cognition.
So there's also some really interesting evidence for the integration thing that you're talking about from brain computer interfacing. So they showed these studies. So if you put these chips in someone's head, like right now, like Neuralink is big or whatever. This was back with some of the first ones. These big arrays that they would plug like into the motor cortex or something. And it takes a lot of training for the person to like try to move the robot arm, and then they have to decode those signals and then turn it into a movement. But as soon as the participant starts to notice that their thoughts are moving this robot hand, all of a sudden they started to notice that the neurons themselves were like wiring themselves to the device to give the device a better signal, right? And so it kind of plugs into what you were saying. Like all of a sudden there's this new module, which is like a chip embedded in your head that the brain is automatically trying to integrate itself with, right? And it comes back to like the stuff that David Eagleman talks about, where like the brain doesn't see or hear or touch or any of these things. All the brain has is electrical impulses, and it's trying to understand these patterns of responses. I mean, when you look at it evolutionarily, we talked about these like first neural nets from these like jellyfish that were basically just trying to like coordinate this movement, right? And then you have these like very simple sensory things that start to come online, where like all those neurons are doing is tying a time thing to something happening in the outside world. But now we have this like really complex brain that's able to tie together so many different sensory streams. And I've talked about it, like when we talk about attention and all of these things, how incredible it is that we have like billions of bits of information coming into our brain at any given time. Like right now, your brain is processing all of the things that you're not thinking about. I'm going to mention your toe right now. You feel it now because I just said it, but you didn't a second ago, right? Your brain was still bringing that in, and it's still integrating all of this stuff and then painting this like this holistic, unified picture for you. That's incredible. I mean, think about sound, right? Sound is this complex pressure wave in the air, and that would be really simple to think about if that pressure wave was just one sound. But that pressure wave is a bunch of different sounds all combined together. It's the sound of my computer humming, it's the air conditioner, it's clicking in the background, it's someone walking down the hall. All of those things are in that same waveform that's hitting your ear. And somehow your brain, with just those electrical signals, is able to isolate where in that wave the different sources of the sound came from, right? I mean, incredible. Uh, and it really kind of highlights this fact that I mentioned being the thing that I like most about, especially the evolution part of what we did this last month, was the fact that what your brain ends up looking like is so experience dependent, because it's making sense of those signals that it's interacting with most often, right? The work that they do with like the motor cortex, with these like all across the animal kingdom, they do this comparative evolutionary biology work where they look at the representation in the motor cortex. And I don't know how many of you listening have heard of the homunculus, but the homunculus is basically this idea that we have a map of our body. Somatosensory, which is touch, right? So we have a map of like all of the different parts of our body where we get touch. But we have another one that's for motor. That's kind of a mirror, not exactly a mirror, but they're very disproportional. The part for our hands is huge because we use our hands a lot. And the part for our back is really small, right? I can touch like 2 points on your finger really close to one another, and you can distinguish that those are separate points. But if I do that exact same distance on your back, you can't tell that those are different points. It feels like I'm pushing the same spot, right? And when you look across animals, the shape of representation is different depending on what they use. So you have like a monkey that uses its tail for stabilization while it's eating, has this huge representation for tail, right? You have this other one that mainly uses like its nose for foraging, has this huge representation for nose. And that's really driven the shape of the brain over evolution. And that's why we talked about there being like different sizes of the regions, not different regions, but different sizes. You have some animals that the entire brain is like cerebellum. And it's because movement is really, really important to that animal.
Right. And there's this kind of like interaction always between, the genes and the experience, the genes and the environment, the nature and nurture, in the sense that, you know, it would, it makes sense to think about genes sort of driving predispositions to engage in certain kinds of behaviors that then,
Yeah.
as you were just describing, drive the development of what the brain ultimately ends up looking like. Right. And even with, so like with monkeys, the way you were talking about it, like, of course, the monkey's genes code for a tail to grow, and then also there's probably some innate wiring there to use that tail for stabilizing on a tree and stuff. But then as it uses that over in time and learns more and more, its brain, especially like its motor cortex and its sensory cortex, are going to come to be even more emphasizing that tail region. Yeah. And similarly in humans, like if you look at the individual level, right, somebody who has a predisposition or just a strong interest in learning, I don't know, to play the piano, right, their brain may already have that sort of innate or what, however it came about, but some sort of predisposition to playing the piano or to music or to dexterous fingers or something. And then as time goes on and they express that more and more, that comes to drive what the development of their brain looks like over time. They're going to have more fine or bigger representations for their fingers and for areas related to processing music and audition and stuff like that. So I just find that fascinating, that interaction between nature and nurture. It's a lot of people want to think of it one way or the other, but there's always that interaction. You can't get away from that.
No, and this, I mean, I think this really allows us to kind of tie in some of these developmental pieces that we talked about, right? Because what you just mentioned is huge, right? Like, really think about this. The fact that someone who plays piano their whole life will actually have increased cortical thickness and a larger representation in their motor cortex for their fingers. Like, they have a different experience of using their hands than someone that does not play piano, because they have such fine acuity and all of these things. Like, someone who plays violin will have a certain kind of representation just on kind of the opposite side of their dominant hand that they use for the bow, right? They have a very different one for the fingers that they're pushing the strings on, and a different representation for the bow because they're different movements and different things, right? So it highlights this fact that as you engage in something, as you devote your attention to something, it literally changes your brain. And I think that that's really important to highlight as we kind of link these concepts to development, right? Because there was a reason why we focused on adolescence, right? We could have just done brain development, but then that would have been like all over the place, right? Adolescence was such a cool period because it's the point in time in which the brain is starting to specialize on all of those things that are experience dependent, right? So we're looking at like these experiences are shaping things evolutionarily. You can see this across species and everything, but it's also happening at the individual level over development as you engage in something. What's really cool about being human is that we engage in thousands of activities, right? Most animals have a pretty routine spectrum of things that they do, right? There's not like a chimp that plays piano and a chimp that plays saxophone and like, or one that plays soccer versus, right? Like, there's so many different types of motor things that we can engage in as humans that shape our brains in very different ways. I think that's like fascinating.
It definitely is. I've been reflecting on the adolescence stuff because I keep thinking back, like it has reminded me how many more interests I had as an adolescent. Like how just experiences were just so much more fascinating and exciting. not Not that it's like, oh, life is dull and terrible now. No, it's just that my interest has narrowed quite a bit more
Yeah.
onto a smaller number of things and types of experiences that I like to engage in. And I still explore and try to learn new things and stuff, but it's not that same sort of like heady experience as when you're an adolescent and you learn. I mean, especially I remember just like early in college, late in high school, it was like anything was just any subject I was learning about in school could just be so fascinating. And I remember this Andrew Huberman quote where he's talking about how when he was in college, he would try to make like if it was a topic he wasn't intrinsically interested in, he would sort of force himself to just pretend that it was the most interesting thing in the world, and then eventually it would sort of take on that character. And I thought back to my time and I was like, it was almost like I didn't even have to pretend. I would just be like, oh, well, the more I study this, the more interesting it'll become. And it just was like this reinforcing cycle. And I think that connects to the adolescence. If anyone hasn't seen that episode, go back and check it out. But what we talk about is adolescence being about this period in the organism's life where it is exploring. It is it's when sensation seeking, that is the sort of the tendency to seek out novel, new, exciting experiences. It's when that tendency peaks in humans, at least, and in many other organisms as well, many other mammals. And it's just this period of learning a ton about the world, so that later in life you can kind of develop wisdom and more efficient, nuanced decision making based on what the vast amount of experiences and learning that you had in adolescence.
There's a some of the coolest stuff that I got into with the adolescence research was actually the comparative biology stuff of like looking at this across species. And one of the things that came out across all of these different species was these four S's of adolescence. That adolescence in most of the species that have been studied, it happens very kind of routinely in mammals, but you see this in fish, you see this in birds, you see this all kinds of stuff. That like the adolescence period is the period in which you're moving away from dependence, you're moving away from caregivers, and you're moving towards being self-reliant. And that requires these four S's, which are you need to figure out how to keep yourself safe, right? Safety. Like there's this, we talked in the adolescence episode about predator inspection. There's this crazy thing that happens with adolescents where they actually approach predators rather than running away so they can like learn how that predator works. And the same thing happens with humans. Like you tell your kid not to do something over and over and over again, they're going to go do that to figure out why you're saying that, right? Because they want to figure out how to be safe in the future. The next one was sex, right, which is huge in terms of like the animal world. We tend to have a lot of like moral things that are attached to that as humans, but that is when our body is turning into a sexually mature kind of form of itself to be able to reproduce, right? And so all of a sudden now there's this like, wow, I've had friends before, but like what is this intimacy thing, like how does that work, and like what are the nuances and the layers to that, right? uh the other one was self-reliance, right? So I kind of mentioned in the adolescence episode, I have a 4-year-old that I feed and I clothe and I brush his hair and I do all of these things that like there's this huge push away from parents during adolescence that like all of a sudden now they're figuring out how to do all of these things themselves, right? And the fourth one is kind of leaving my brain right now, but what I really kind of wanted to paint the picture of with a lot of this kind of movement that's happening during adolescence and connection to evolution. This might be controversial. I've heard kind of allusions to this in some of the talks that we've kind of listened to, but that the developmental periods really drive a lot of the change that ends up pushing evolution in one direction, right? And to me, that I think makes a lot of sense, right? Because you have this period in time where the animal is very driven to do different things than they've been raised to do. And so it's pushing them to explore new niches. It's pushing them to explore different ways of interacting with the world, different ways of interacting with predation and interacting with mating and all of these things that I think can start producing kind of these plastic changes in that period of time. I don't know what then happens with epigenetics and how that may like propagate on a population level and create something different. I've always thought that just the random mutation idea of evolution is not the whole picture. Um, But again, like I said, this could be controversial. But you could look back at the very first movement in evolution for like multicellular organisms. It was the adolescent polyp stage of the sponge that became the first jellyfish. And so it's this interesting idea that it's this point of movement.
Yeah, well, and it's also, as you mentioned, a point when the organism is becoming sexually mature and starting to have sex, and therefore starting to reproduce. I mean, not so much in modern humanity, but that's the norm, right? I mean, especially for the history of our species, like we're later and later now we're moving later and later to having children, right? I mean, I'm 29 and I don't have any kids, and I don't know if I will or not, but like the point is that it was earlier in life when people would have children, especially because like life expectancy wasn't as long. You didn't know whether you were going to live or die at what age, and all that. So to your point, maybe there is something to that, where at this point there's all this sensation seeking, right? There's this high degree of exploring new experiences, doing new things, sort of expressing individuality in a certain way, as well as the sort of need to be in a social group. But combined with that, the start of sort of the reproductive years, right? The time when we're starting to have babies, and we all know the key to evolution is reproduction, right? So maybe there is something to, I mean, now it's starting to seem obvious in my head. I don't know if this has been like empirically validated or not, but the way that, since part of probably what drove sensation seeking to uh, evolve in those years is maybe that it leads to reproduction, or that there's a relationship between those two. But yeah, I hadn't thought about that. That's really fascinating.
Something that was really interesting that you kind of hinted at there, that it kind of shocked me when we got into some of this adolescent stuff, was that the adolescence of today is like 3 times as long as it was less than 100 years ago. Uh, that just like blew my mind. And I mean, one of the things that we talked about was that puberty is happening earlier. We didn't really mention why, and there's some really interesting kind of data on, because it used to be about 14 and a half for girls, and now it's down to like 12. And they think a lot of that is actually obesity. That
Hmm.
if you have higher fat count, you actually go through puberty earlier. And they show that
I
like
like that
girls
way of
that
saying that, higher fat count.
right, yeah. If you have a higher proportion of fat cells, it pushes puberty to start earlier. And that makes sense actually, right? Because if you have a higher fat cell count, you have more resources to support holding and carrying a baby full term, right? If you're rail
Hmm.
thin, right, and like thinking about it, it's just the body doesn't feel like it has the resources to be able to go through that whole ordeal. And so there's a lot of evidence that shows that like there's a link between the amount of fat content and the onset of puberty. There's also a lot of stuff with like trauma and things like that that'll push puberty back. And I think that has to do with kind of forcing the body into a position that it wasn't ready to be in, and then it's just trying. Uh, but the other thing that's coming up too is a lot of endocrine disruptors that are in products that we use, in kind of lotions and all that kind of stuff that actually kind of disrupt the hormones that are kind of responsible for puberty. There's one that Andrew Huberman talks a lot about, that I mean, I've completely steered away after learning about its link to adolescence, is melatonin. Uh, the melatonin that you can buy over the counter is actually like way higher of like a dose than you actually have naturally. And what a lot of people don't realize is that melatonin is actually a huge signal for pubertal type stuff. And so it's not something that like is the greatest for adolescents. And there might be some links to early puberty with that kind of stuff.
That is really interesting. Yeah, that the like, sort of expansion of the adolescent period, it goes back to this biology and, well, I guess gene and culture and environment and experience interactions, right? It's like
Yeah.
there's got to be. I don't remember looking into this for the adolescence episode, but I'm sure that there are genetic correlates of sort of the onset of adolescence and the types of changes that occur there, maybe epigenetic expression. I mean, it kind of has to be in some way, but when it comes to the cultural element of that, yeah, there's this expansion of adolescence, and I think largely because society, we've gotten much richer over time, much wealthier. As you look at pretty much anywhere on Earth right now, and you go back 1,000 years, even 500, even 300 years, it is much easier to survive in terms of just material wealth than it has in any other time in human history. And so like our ability to support our children for longer and longer periods has been going up. And so kind of no surprise that maybe this period of learning to be independent, and then something you mentioned in the last episode, the need to develop more specialized skills and expertise to actually participate in the modern economy is also growing. So there's this interaction there. But yeah, I think it's important to like take the biology and the culture again into account, because that's going to have that's really not just the culture, but the environment and the experiences of the organism along with their genetic predispositions. That is going to like lead to the answer in pretty much every case.
I think that's what's so fascinating about some of these topics, right? There's like there's this really cool biological underpinning, but then there's also these other layers on top that make this such a fascinating topic, because we can't just ignore one or the other. Because like there's some people that like live in the world of biology and like, you know what, everything's predetermined, like this happens and this happens, right? Which like we have a whole episode on free will if you want to go check that out. But it really kind of paints this picture that we have to step back a little bit and look at how all of these things are interacting in this really interesting way. And something that hit me. This is kind of a tangent, but it's very much in line with kind of the things that I'm just fascinated about with evolution. You talking about this idea of being kind of richer than we ever have been. I see that concept come up in evolution in general. Looking at the cellular level, right? Like a lot of what I've done, like my whole channel being called the Cellular Republic, is this idea that I have that like evolution itself kind of mirrors in a way the evolution of society. There are these really interesting kind of parallels that you can draw in terms of how information flows through the system is very kind of similar in terms of like hormones travel really slow. So did horse drawn like messages from one town to the other, right? And then you have like electrical signals from neurons or like radio signals in society that allow this communication and this coordination at this much kind of higher level. But one of the things that I've always been really fascinated by is the growth of these different areas, I think, is dependent on richness, like you were talking about, that there has to be abundance for them to now try something new, right? That all of a sudden there's just like, okay, I'm going to start pumping a bunch of resources in here because we don't really need to be looking for water right now. We got a bunch right here. So let's like develop something new. And you see that in society, right? You have a society that all of a sudden, like agriculture, we have these huge like stores of grain. We live right next to the river. All of a sudden now you have all of these jobs that used to be going out and foraging and hunting and all of these things that now can be allocated to something else. That those cells can actually try to do something different. Those individuals can try to do something different. And again, a lot of this is speculative. It's me kind of thinking about like, what are these kind of forces that are pushing thing in one direction or the other? And it relies a lot on the fact that these cells are alive in a certain way, right? That they're engaging in the biological world that they're in. And now all of a sudden, if they don't have to do some job, they don't just sit there doing nothing. And they're like, oh, I could maybe do this. And then all of a sudden it works and it's functional and it helps. Just a kind of a wild idea, but I wanted to throw it out there.
I think that was something that sort of brought us together to do these podcasts in the first place. Was we both had this intuition about linking social systems to biological systems in like an analogy type of way. And I mean, I studied biology in college, cellular and molecular biology, and then after college, I got really interested in economics, and I'm a like I'll read books about economics. I'm not an economist. I don't have like the math background required to really understand the literature and stuff like that. But I'm really interested in it, and I see a lot of parallels in like the big
Yeah.
principles, things like metabolism as a kind of analogy for currency, for like the flow of goods and services and money through the economy. That's a really, an economist would point out where I'm wrong on this and that. But what I wanted to get to was in this in economics, there's like this phrase: "There's no such thing as a free lunch," right? So there's always trade-offs. There's no, wealth, things don't just come out of nowhere, right? People have to make them, and their resources go in, and then something comes out, and there might be a net gain from that, right? But there's no just magic basically in the world. There's always this flow of stuff. And why I'm bringing that up in the context of evolution is I was reading this article this morning where they were talking about some studies that looked at how human brains, certain genes have developed in the human species in a way that basically created a trade-off between our muscle development and our brain tissue development. And so like I think we've mentioned this before, but like the human brain takes up 2 or 3% of our body weight, and it takes about 20% of our energy, our metabolism. So that's a hugely disproportionate, like a very expensive tissue, right? And there's some evidence suggesting that part of the reason that we're able to, quote unquote, afford such an expensive organ is that we made a trade-off with, okay, we're not going to put as much into developing, or we're going to sort of shunt energy from our muscles and into the brain. And they can show this looking at the chimp version of some of these regulatory genes that are important for the energy metabolism in neurons versus muscle cells. And they put the ones that are for neurons into mice, right? They do this genetic engineering. And what they find is during mouse development, the ones that have the human version of this gene compared to the chimp version of the gene, their cortex, their brain develops to be 12% larger at the same time point. So, and then there's some other stuff looking at how chimps and monkeys, primates, like non-human primates, are stronger, disproportionately stronger than humans, even accounting for body size. So that just, another way of kind of pointing out these parallels.
No, and it really kind of highlights some stuff too, because what is driving some of these trade-offs, right? Because there has to be a reason why we don't need that strength anymore, right? And I think a lot of that, I mean, chimps are social too, but there's also very kind of rigid kind of status hierarchies in chimps that still kind of exist in humans, but not to the same extent. I think that we're maybe more like the bonobo line of of that kind of thing, right? There's, I think, less of a need to protect ourselves because of the way that we were social, right? We had this really interesting way of banding together, of sharing resources. I think this comes back to our idea of language that we were talking about earlier. I think one of the things that really drove the evolution of language was coordination, right? You see this with chimps. If you've ever seen Chimp Empire on Netflix, it's fascinating the way, like, when these chimps are hunting, that they're coordinating with one another. And it's their form of language, right? It's not this really abstract language that we have, but you can see it as kind of the beginning of, now once we develop kind of the vocal cords and the ability to start turning some of these, like, you go do that and I'll go do this, into actual like concepts and words that can be communicated, how powerful that actually becomes. That now we have this incredible coordination ability where it really highlights societal evolution, right? That once language comes on board, I can say, you know what, I'm gonna do this, like this blacksmithing, and you go do the farming, and you go do this, right? Like, I can actually communicate that to you instead of just like, If you're listening, I'm pointing, right? Right, like uh, there's this incredible nuance that comes with symbolic language of being able to really say, like, this is my position, this is what I'm going to do, and that's what you're going to do. And I think that that really kind of highlights something that's unique about our adolescence, right? We talked a lot about our adolescence being about kind of individuality, about identity exploration, and all of these kind of things. And language adds a really interesting nuance to that, right? Because if you think about like the evolution of society, I do this, you do that, then adolescence is really about this internal chatter of like, where do I fit? What is my job? I do this, you do that, like, what do I do, right? And you go through these hoops and you jump through all of this stuff to really kind of wrangle that and understand, like, where do I fit into society, and like, how do I relate to these other people, how do I relate to my peers, how do I relate to intimate partners, right? And it's just really really fascinating that like you see all these similar behaviors across adolescents and other species, but the identity piece is so much more salient in humans, and I think it's because of the like language piece.
Yeah, that is so cool. Yeah, I know. Like I love. This is obviously an anecdote and not connected to any research whatsoever. But I know, like when I was an adolescent, that was when I started getting really interested in reading and writing. So probably not have anything to do with large scale, evolution or development of human beings. But for me, adolescence was certainly a period when I started exploring and kind of mastering language in a new way. So there you go. There's a one data point for your theory.
No, and I think that putting these things together, one of the things that we really wanted to kind of get at, there's a phrase called ontogeny follows phylogeny, and it's this kind of fancy way of saying that developmental processes seem to follow evolutionary processes. Andrew and I kind of chatted about this before the show. There is definitely some nuance here, and he can maybe speak to some of that. But kind of generally speaking, we do see some of this in terms of brain development, right? That the parts of the brain that tend to develop last, the kind of prefrontal cortex, especially the parts that are involved in kind of long-term abstract thinking, the ones that evolved, that are like the newest form of like the human brain, are the things that tend to develop last. Some of our capacities with like the insula and being able to really kind of understand and communicate what we're feeling, those are some of the things that develop kind of later in life, right? uh, but the things that develop first tend to be the things that are really necessary for like navigating the world: sensation, seeing, hearing, and then moving. And even like these things that we talked about in the adolescence episode of like being able to motivate my behavior, dopamine and serotonin, like mood and all of these things. Those things are all kind of coming online and kind of being refined. But then adolescence then becomes this period where we're like, okay, now we're going to take hold of all of these really cool new like human tools, and see what we can do with them.
Yeah, it's really interesting. I think about the nuances, like when a lot of people are talking about the idea of uh, ontogeny recapitulates phylogeny, so development follows or sort of summarizes evolution. A lot of people are thinking about embryonic development and looking at how the embryo develops and then comparing that to, does this look similar to how, the grand scale of evolution from fish to humans. And I think from what I've read, most evolutionary biologists today think that is certainly not like the whole truth. That's an oversimplification, and there's a lot of different ways of seeing that. But then on the other hand, there is something to it. It's kind of similar to this triune brain theory that we started out with. That it's not true in like a strict sense, but there is something to it. There's something helpful in thinking about both development and evolution. And I think in this case, like one interesting thing when you're talking about embryology and you see the development of, you compare the embryonic development between vastly different species like fish, lizards, mammals, primates, humans, there are points during their embryonic development where if you take snapshots at various points, you see they do look they'll look very similar, and then as you move through that progression from zero to birth, basically, you see more and more differentiation. So the fish look less and less like the rest of them, and then, so it like we do split off, and there's something to that, like looking at that. Okay, maybe there's something to the idea of like um, early embryonic development has some correlate in early kind of evolutionary development. But then like what you're talking about, kind of moving past birth, like into the actual development of the human brain and the human throughout our life, and seeing if does that have a correlate in human evolution. I think that's something that has probably been talked about, but it's talked about a lot less than this idea of during embryonic development. So I just want people to know, like, we're not endorsing this idea of phylogeny ontogeny recapitulates phylogeny in its strong form. We're saying there's something to it, and there may be something to it with regard to adolescence and human evolution.
But I also still want to like put the caveat. Something that we tried to really kind of push in our adolescence episode is that just because the prefrontal cortex isn't completely developed in adolescence doesn't mean that adolescents are stupid or like unable to control themselves or any of these kind of things.
They're
Like
not monkeys.
That's not true. They're not monkeys. Yeah, that's right. That like adolescence is a really powerful time of life, and I think that something that was really interesting in terms of connecting evolution and development is really putting a lot of the behaviors of adolescence into an evolutionary context. That's really helpful in understanding behaviors when you can see how they play out across these different species. When you see that this risk taking, this sensation seeking, this novelty seeking is really common in every kind of animal you look at during that period of time when they're leaving kind of the dependency of their caretaker situation and going out and becoming a self-reliant adult, whatever that means for that species. It kind of paints this picture that like undeveloped prefrontal cortex is not the explanation, right? And I mean, you go talk to like a pediatrician that like why do adolescents do this? Like it's pretty common, and it's as common as kind of the triune brain theory. Like you ask someone about the lizard brain, a lot of people know about the lizard brain, right? A lot of people think that like this undeveloped prefrontal cortex is the thing that defines adolescence. And that's something that we really wanted to kind of highlight, was that nothing makes sense except in the light of evolution. And when you can really put these things into a comparative biology framework and understand that these behaviors have purpose, that they're pushing the behavior in a direction towards self-reliance, that it gives you the ability to actually support those behaviors in a healthy way instead of just pathologizing them.
Yeah, that's a really good point. So, and then as you were saying that, I was thinking about, evolution adolescence as this period of exploration and sort of individuation and learning so much about the environment. If I were to just be like, do some wild speculation and think about the evolutionary past, if we talk about periods of evolution when there were major explorations of new environments and that leading to sort of like explosion in new species, you could think about the change from animals purely living underwater in the ocean, and then that gradual evolution to them living on the land and exploiting this entirely new environment and ecosystem of resources. Again, I have no data, nothing, no theory supporting what I'm talking about right now, but it's interesting.
That's exactly what I was trying to get at earlier, right? It's just that like once you see like how cool adolescence is, and you see these like specific changes in terms of like dopamine expression, right? That like the baseline lowers, the phasic stuff, the like peaks above baseline get higher. That itself pushes novelty. seeking, right? It's like I need to go out and I need to explore the world, right? You now pair that with epigenetics, right? Okay, now I'm an adolescence that just discovered a new niche because I left my home. I left this comfortable little cove that I was in. What is this land thing? All right. And then you start kind of flopping towards it, and your epigenetics start expressing something that like allows you to get closer to land. And then all of a sudden you're also at the same age where you're reproducing. Like, does some of that get transferred? Because I think something that I've always struggled with just this pure Darwinian, like random mutation view of evolution, is when you look at kind of the editing components of DNA, how like when a mistake happens in DNA, there are like machinery that find those mistakes and fix them. Like a lot. And so it's just like, how is it that with this like fixing machinery and this random mutation stuff, that the mutations tend to be something that is very beneficial for the species? And I get that this is like a population thing; it happens over a long period of time. But it's just like, okay, the species just happened to become the perfect color to match these rocks that the hawk didn't eat it, or something like that. That like I feel like there's more interaction going on between the biology and the environment than just pure randomness, right? That like, and it's the reason I think that is just because of how plastic the brain is, right? If I can completely change this kind of expression in terms of how things are represented in the brain, just because of the way that I'm interacting in a motor way with the world, is that then you have this animal that all of a sudden needs to dig to find food and is digging and digging and digging and sending resources to its hand over and over again, that all of a sudden those cells start to develop a new way of interacting with that dirt. I don't know. Again, this is purely speculative, but it kind of paints this picture that this kind of transitionary period where the brain, possibly the body, is very plastic, kind of paired with possibly some epigenetic stuff that can get passed down, might be something different than just this like, oh, they just happened to get this new thing that was really beneficial. I
Well,
don't know.
no, I hear that. To defend the Darwinian view,
Gotcha.
I
I
would
knew it was
say,
coming.
well, it could, because it's not fully random. The mutations themselves are random, right? And that results in most of these mutations either doing nothing or being bad
Inferring an
for the
advantage.
organism, for the
Oh,
survival or
yeah.
reproduction, right? And then the ones that are good are the ones that are actually preserved, because those are the ones that lead to greater ability to survive or reproduce. Um, so I would just say that it's what we see, this amazing adaptation to the environment, is kind of like it's like a carving away of everything else that didn't work. But it's not really that. It's that what worked is the thing that survived through the eons, right? But I understand also what you're saying, that there, especially with the brain, especially with the nervous system, there's this incredible adaptive nature within the life of the organism, and that could lead to even changes that are perhaps preserved somehow in the genome or epigenetically. Like, right, we know that epigenetics is a thing, and that people, the Dutch hunger winter after or during the Holocaust, after, I'm not a historian,
I think
right?
it was
But there
during.
was
I think it
a
was during the war.
time
Yeah.
in the 20th century when there was a famine in the Netherlands, and people who are descendants of those who lived through that famine tend to more easily put on weight, right? They're more likely to be overweight or obese because they had these epigenetic changes, or their ancestors, right? Their grandparents had these epigenetic changes that influenced the way that their body stores fat and things like that. So I could definitely see, and then this again goes to this very intricate, very complex interaction between behavior and the environment and culture and genes. And so I'm not saying like it's all, again, it's all nature and there's nothing to what you're saying, but I had to stick my neck out for the the Darwinian worldview
Right.
there.
And it's like, because and I don't want people to think that I'm like falling on the side of like creationism, like the eye is
No,
so
no.
perfect, how could it have ever just like randomly be created? What I'm kind of thinking more, and again, this is just kind of a pet theory of mine, but is really more about it's experience dependent. That if this animal now is in a new niche that is causing them to interact with the world in a fundamentally different way than they used to, is that way that the body is now interacting with the environment changing the body itself? And are those changes that are happening to the body, that are happening to the brain, somehow being preserved in kind of an epigenetic way that's then passed down? And I don't think that we have the ability really to study some of that stuff, or to look at it. And I don't know enough about this kind of stuff. So again, this is kind of speculative, but
I don't think it's that speculative. I don't think it's that I think it's just that the like what's the mechanism that it is actually
yeah,
preserved by. And I
yeah.
think it's you're not like you don't sound crazy in any way.
But I think these two topics were really fascinating to do together, right? Really looking at kind of how did we get here as a species over billions of years, right? I mean, we covered a lot of ground in an hour in that evolution episode, looking at single cells and how they come together to form these big multicellular organisms that become so intricate, and so many things are going on. Uh, to now being this like small baby, like Andrew talked about not having kids. I've been through it, right? Like you go through like incredible dependency. I have you have this period where you're very kind of like you need to do everything for this, and then you watch as this thing kind of as this person interacts with the world and becomes. I think something that really kind of sticks out for me is what I'm getting at is that I think as adults we take for granted a lot of what had to be done through development. That like that we can just like walk through the world no problem. We can like use our attention in this very kind of oriented way, and all of these things. Those are all things that we had to learn through this developmental process and had to refine through adolescence. That we had to like then say like, okay, what are the things, what are the strategies that are most useful in my life, and how do I kind of amp those up and really bring them forward into adulthood? That if we take that process for granted, if we take the whole evolutionary process for granted, we take ourselves out of the position of being able to have any kind of force that we can put onto it, right? Like we can actually change these things. We can change the trajectory. We can change the cultural ideas about what these different periods of development should look like, right? How we can support these different parts of development to really bring down the mental health crisis that we have in this country, right? Teaching these children how to engage in emotion regulation instead of just saying they don't have the brain areas to do it. Realize how experience dependent so much of this stuff is. That like they're not going to learn how to do these things. They're not going to learn how to walk unless they're given an opportunity to walk, right? That it really kind of links all of this into this kind of experience package that I think has just been really cool across both these episodes.
Definitely. Yeah. Well, I think we're running up on time. I don't have the clock here, but it
Yeah,
seems
no,
like
we
we
are.
are. Um, yeah, but I think this has just been really, really fascinating, really interesting to dive into all this stuff. And I hope everyone out there is enjoying this as well. And if you're listening at this point in the episode, it means you're a
Yeah,
Patreon supporter. So thank you for
thank you.
supporting the show. And yeah, we will definitely be back, I think, in it next week or the week after
Maybe.
sometime. Anyway, yeah, we'll keep you posted, and thank you guys for continuing to support us.
Yeah. No, it's we very much appreciate the support. Like Andrew and I love doing this. This is kind of wild that we have done 40 episodes together. I think we're on, like, including the Patreon episodes and everything, we've done more than 40. And that is just wild. And to think too, Andrew and I have never met each other in person. I have no idea how tall he is. Right?
I think Taylor might be an AI, actually.
Like, we met purely on YouTube and started doing this just because it was so fun. It was a reason for us to really dig into this stuff that we were fascinated by and to learn more. And I really hope that us doing that has imparted some of that to some of you. And just kind of mirroring what Andrew said, like, even though we love doing this, we absolutely love the support, because it helps us kind of maintain the motivation to do this research and to listen to all these conference talks and read all these papers and everything. So thank you for continuing to tune in.
All right. See you next time.